right. Looks good, and we'll get going here. I will start with our introduction. We are on day 3 of the ALTI 10th annual virtual solar conference, our first virtual conference this year. Thank you everybody for coming. And today our first session is with Morningstar, followed by Kilovolt and Schneider Electric. And then we have an open networking session at 3 p.m. to end the day with all 3 of those manufacturers. So we would love to introduce Brad and Kyle and team from Morningstar, and they will take it away. Thank you, guys.
Okay, thanks very much, Andrea. Yes, so welcome everyone, and Morningstar is really pleased to be participating in this event. And of course, thanks to everyone at ALTI for being able to offer such a great show in this virtual environment. And my name is Brad Berwald. I'm a product manager at Morningstar, and I'm joined by several of other staff members from Morningstar, Mark Cerasuolo, our marketing director, Kyle Willsey, who is a sales engineer, and Michael Sherman in inside sales. So we're all available and hopefully be able to answer your questions and talk a little bit during the networking session later. Just to remind everyone, there is a drawing for a Sunsaver MPPT controller from Morningstar, and also with that, we're going to be including an EMC1 adapter, which is our Ethernet adapter. And that's a fitting combination because the discussion today is on controller data, connectivity, and what you can use the data for to best manage your off-grid solar systems. So with that, I will go ahead and get started. What we'll be covering during this presentation is a little bit about Morningstar's product line, which I think many of you are quite familiar with. And then I'm going to talk more specifically about the data aspects of the product, so on how to get that data, but also how to interpret it and some questions you might want to be asking when you're looking at specifically off-grid system data in order to find out how you can best improve your systems, make design changes to manage them going forward in the future, and just generally improve them. You'll see that in your managing one site, there's a lot of a kind of a deep dive you can do specifically with that site. But since a lot of what Morningstar does is, large off-grid deployments, systems, security equipment, industrial applications, monitoring of a large scale number of systems in the field, we're also going to talk a little bit about how to monitor those systems en masse in great quantities and how you can do that with a lot of the sophistication that's available with internet connectivity today. Okay, with that being said, I will go through a little bit about Morningstar. Over 4 million products in the field since our inception in 1993. We've been doing this a while, and many of the team here that is joining the call as well has many years of experience. We're selling products in over 100 countries and really targeting mission critical applications in all sorts of verticals. So residential and rural electrification, home systems of all types, commercial applications. We do industrial, specifically telecom, oil and gas, and security, really key high reliability applications that really depend on the quality of the product to make sure that they're up and running. We also talk a lot about mobile and marine agricultural systems, pretty much anything. And if you're familiar with our line, we're targeting small, mid, and even high power, 12, 24, and 48 volt systems. So a lot of applications to cover there. We think of ourselves as the charging experts because we've got a very wide and diverse product line, and happy to say we've got the lowest failure rate in the industry. So just a quick shot here for one of our products, and you can kind of see what goes into them, the core features and products in the technology of our circuit boards. All of our products are built by our own engineering team from scratch, and we use a lot of unique design attributes for those to really make sure that the features are there, the quality, the communications abilities, which we're talking about today, and you can see why they have a long warranty, a long life, and that we've got so many existing in the field. So the topic today is to cover real world questions about site data. Monitoring applications are becoming increasingly popular. I think every year we get a greater and greater percentage of customers that are asking about or even expecting management or remote access capabilities, whether they're getting the data from the controller's data logging itself, or they're talking to it around the world on something as extravagant as a satellite connection. Those are all possible. And as the technology advances with networking, you're going to see more and more of those controllers want to be connected and online. And the nature of off-grid, we're doing remote cabins, mountaintop, telecom repeater sites. There's no better application to get remote monitoring than one where you've got to literally climb a mountain to get to the site. So we want to prevent you from having to do that. Stay out of the helicopter rental business and just stick with remote applications where you can get the data right on your PC. So when we look at some of what I'll talk about today is the health of a single site as well as managing at scale. So how do you manage hundreds of sites, maybe even 1,000 or more across a large deployment? And we're seeing that very common in telecom and security and other applications. And we can talk a little bit about, in that monitoring, specifically looking at power production, how the battery charge behavior is taking place. Is that battery being recharged? Is it healthy? The load behavior, the equipment that you're actually running. Often the critical need of the customer is for lighting or security equipment or a telecommunications link. How can you keep that reliable and see what's happening with your load? And then lastly, I'm going to talk some about our string sizer because understanding the data at the site gives you good feedback so that you can use the string configurator and you can provide, the latest modules. You can make sure that the MPPT controllers are best being utilized and that the battery's getting a full charge. So we'll talk a little bit about some of the improvements to our string sizer, and I'll give a brief demo on that at the end of the presentation. Okay, so Morningstar's product line, or in this case, the data-enabled products, which is the majority of the line, include the Tristar, ProStar, and Sunsaver classes of families of products, and also includes our SureSign inverter as well. That's our 300-watt pure sine wave inverter. So all these products have data capabilities combined with our EMC1 adapter. They can also have IP or Ethernet capabilities. So you've got a lot of choices there. And we're going to talk a little bit about some of the protocols, and everything that's discussed today is going to fall into either one of two categories, either Modbus communications, which is a standard communications protocol used by SunSpec and many others for device control. You'll see it on grid tie inverters, and a lot of system gateways will be able to read Modbus data. And we'll also talk a little bit about SNMP, which is a newer protocol that we've begun offering support for, because simple network management protocol is a really common way to get data from telecommunications and security sites. So between those two protocols, you've got a choice and can provide connectivity in just about any environment, whether it's with Morningstar software or with third-party gateways or even the cloud. So we'll be going over that. So let me walk through the products just briefly. I want to get to the meat of the discussion, but I want to make sure everyone's familiar with the product line that we're covering today. So first discussion is our Tristar family, which includes both our MPPT and PWM solar controllers. This is really an industry leader in industrial applications. It's our largest product right now in terms of total power output at 60 amps at 48 volts, or about 3.2 kilowatts. They can be used in parallel. They can be used for residential systems as well. It's often paired with an inverter and will be the PPT of choice for maintaining a battery bank for an off-grid home system. Fanless design, really long-term reliability. And if anyone is familiar with the Tristar line, it's been really a rock in the industry and all applications for quality MPPT charging. Fanless design and 99% efficiency. So you'll see it here featured. We use this in telecommunication sites as well because of that reliability, and many of them paired in parallel can be expanded to provide 10, 15, even 20 kilowatts of PV charging in an off-grid application. And another related product to that is a 600 volt Tristar. So similar power output, also a fanless design, but with a high voltage input. So if you're looking at 600 volt connectivity, an array wiring, similar to what a grid tie inverter is offering. If you need long distance wire runs, high voltage DC to reach an array that's over quite a great distance, the 600 volt controller is also a good option and has many of the same charging capabilities and MPPT tracking as the original Tristar. The ProStar family, this also includes both MPPT and PWM. And this product, we have several different models with and without meter, and we speak to both PowerPoint tracking and still an industry standard, the PWM line as well, for when you don't necessarily need tracking or you're using a nominal voltage array. And all of these products offer communications capabilities, UL listings. They also provide the meter built in if you wish to get that model. And most importantly, this product offers built-in load control. So when we're talking about an industrial application where it's unattended and there's a DC load and it needs to be managed, remotely and in an automated way, the load control is offered on all these products. And that's important because when we look at some of the data discussions today, you're going to see that, knowing what is coming into the system from the PV array and also what's going out is really critical, because if you don't have that data together, you're not going to be able to see that you have the right balance on the array for the battery, that you're not going to see what your load is actually consuming. A lot of customers are sometimes they have some estimates for the design with load, but they don't always have all the data until they start getting the equipment in the field. And in the case of this is a railroad application in this photo, understanding what a lot of this equipment actually draws, and you can trend it over, time periods and over the seasons, gives you a much better understanding of what to expect for future designs. So the Sunsaver line, again, MPPT and PWM variants of the Sunsaver, and this is kind of our industrial workhorse, also very popular in marine and boating applications because it's got a sealed epoxy coated circuit board and really corrosion resistant. So we've seen that as a favorite product in the marine industry, and also just about any kind of harsh environment where you're really looking for an extra degree of mechanical protection. The Sunsaver also has a Class 1 Division 2 rating. That's why it's used in a lot of these industrial sites, and we see that with oil and gas, also mining applications, and it's really a standard product there as well. And as I talk about all these products, you'll see at the bottom there the logos. As long as they have our RJ11 jack, which is usually for support of system accessories or our remote meter displays, it's also compatible with the protocols for data that I've been discussing, which are Modbus and SNMP. So that's covered in all of these products. And there on the right, you can see the RJ11 jack, and any products enabled with that, we have the monitoring capabilities that I'll be talking about today. Okay. So core features of the Sunsaver PPT, you get high frequency designs in all of our products. That's why they're very efficient and also fanless, and a lot of the electronic protections built into the product. There you can take a quick view of the epoxy resin, which is also a standard in the majority of our products. Okay, so moving on a little bit, and again, we'll have time at the end for questions, and I know that several of my team that has also joined the call is going to be addressing some of the Q&A during the call. I'm just going to be focused on the presentation itself, but as you have questions, please get them entered into that so that we can get back to you. We can also do that after the fact. And I believe, as I mentioned earlier, that there is a networking session that's going to be later this afternoon, which Morningstar will be in attendance with, and you can speak to many of us then as well. So a brief overview here in the details. All of the products have our RJ11 connectivity, and then with that connectivity, you can convert into RS-232, EIA 485, which is a multi-drop serial connection, as well as gain the ability to provide Ethernet capabilities. Okay, so those are the standard features on those products, but any of the products that have the RJ11 can have those additional options added with some of the accessories. So there's really not any of our products that can't also use Ethernet connectivity if that's what you wish. And we see that becoming more common, as I mentioned earlier, 4G modems becoming lower cost, data becoming cheaper as well, satellite connectivity really going through a lot of changes this year, and a lot of private networks being deployed in applications. So what I'm going to talk about is we have kind of three core software options for connecting to our products in order to get data. And each of them has kind of some strengths or weaknesses depending on how you look at them, and helping you to determine which is the best for getting data is what we wanted to talk about today. So I'll start on the right here actually with Morningstar's MS View, and that is our PC software that allows connectivity to a few devices at a time. Really, it's geared towards a single device so that you can collect downloaded data from the product. You can do logging. You can actually provide changes in set points remotely, such as new battery configurations, which we'll be discussing. And it's really a utility as well as a data tool that Morningstar has offered for some time. The Morningstar Live view in the middle column there is our web page view, and that is enabled in products that have Ethernet as standard, or it's added by when you add the EMC1 adapter to any of our products, you get that live view page. And that is a very simple way to display that same data, but in a web browser. And that's great because it's device agnostic. You can view it on an iPhone and Safari, you can view it on a tablet, you can bring it up on any PC or Mac browser, and it's a quick and simple way to pull up information. A lot of home users like it as well because it does not require internet connectivity to the cloud. It can be served on a nice web dashboard right from the product itself. So live view is a simple way, but with more limited data features. And then lastly, we'll be talking about if you are interested in utilizing third-party devices, third-party, gateway devices or software tools, we can also provide connectivity. And this has been done with Modbus for many years, such as renewable energy management software that's been online, which we are supported by, and more recently with SNMP, which takes a lot of the software that is used for monitoring network switches and equipment and gives you the ability to also monitor the solar controller at the same time. So if you're already doing this type of management with a software portal, a single dashboard of many devices, you can also add the solar controllers to be part of that same view. And they call it a single pane of glass, so that you don't have to leave one tool and go to the manufacturer's site and log into their tool. You can get it all in one place. So we'll be talking a little bit about that. When you look at the features, you can see that as we get into scale, the needs kind of change, and you'll see the strength of the cloud management tools becomes a lot stronger because you get much more log data. You maybe have a database that you're putting it into where you're accumulating a lot of information. The storage capacity is unlimited. You can see historical data, manage multiple sites. And also, since it's being managed in the cloud, you have the ability for the software, instead of you checking on the site and logging in to see how things are going, the cloud will actually monitor the data and alert you based on pre-configured notifications, like a low battery voltage or a site has gone down or excessive, load draw or temperature impacts, things of that nature will proactively come to you, because when you reach hundreds or even thousands of sites, that's really the only way you can monitor something of that scale. So in a standard system setup, this is the kind of configuration you'll see. We've got our common loads on the right and a variety of applications. They could be home, industrial, or commercial. Our ProStar MPPT is a good example product there with an array and a battery connection. And then our EMC1 is going to connect to an internet router and provide you connectivity. And then from that, you don't have to choose just one tool. You can actually use multiple that overlap. So in this case, when I talked about having Modbus or connecting to the site with our utility software MS View, because you need to make some changes to the site, you can do that. At the same time, you can view the HTTP web page to get a dashboard view simultaneously. All at the same time, you can also be using a centralized server to be collecting data from all the sites, en masse. And that's done with a network management system or other type of cloud server. Okay, so you don't have to choose just one. They all, just like a lot of PCs, they can run a lot of software at the same time. The EMC1 addresses all of those needs simultaneously. It's like a very low cost, low power server of sorts that sits right next to the controller. So some of the things we wanted to talk about, and I'd like to bring up some examples of data displays, is, everyone says, well, I want to log in and I want to see what my battery voltage is. Is it high? Is it low? Is my site up and running? But there's so much more you can actually interpret from the system if you've got more data. And really, that's speaking to better data, more granular information, taken more regularly, like every hour, every 15 minutes, maybe even every few minutes, so that you can kind of see the impact of what your system is going through. And there's a lot you can learn from that. And we kind of pride ourselves in, sharing that expertise and working with customers to kind of make that interpretation to see what's going on and give you that insight. So with that data, there's a lot you can view. When you start looking at day over day changes in the system, you get a sense of the behavior of the site. And when you look at weeks or even say a month time period compared to a seasonal change, such as winter versus summer, same system, hopefully same loads, same PV array, but what is the impact on the cold climate, the low temperature on the battery, the decreased solar production, and then when you get that year over year view long term, you can start to see, get an idea of the maintenance of the site, because batteries, they've got a long life. Lithium has an even longer life, but they do degrade, and it is something that'll have to be replaced over time. And when that occurs, you want to be able to kind of predict when that's happening, because maintenance at the site is expensive, and having that predictability, or even better, predicting when a site is, maybe ripe for a replacement of the battery before the load goes down. The way to see it coming is up much more ideal, rather than having the customer call you and say, yeah, we lost the site, our equipment is down, I guess it's time to change the battery. That's what they call finding out the hard way, and we want to prevent that. So when you look at power production, you get a good understanding of what is the array producing. Make sure there's no shading impacts. Seems pretty straightforward, but even in off grid, when you have the ability to place the array in different locations, there's sometimes shading that you're not aware of, depending on the time. We do a lot of applications in traffic equipment, and we had a customer that one time had deployed some traffic systems and was able to monitor them over cellular, because they changed the display, and they were monitoring several of them, and one was behaving particularly bad, and they went to the site and found out that it had been parked under a bridge. And that's where they wanted to inform the customers of some traffic incidents, but obviously not a good location for solar. So the shading impacts, making sure there's not high voltage alarms, is current limiting occurring, meaning that there's maybe some high temperatures, or the array is putting out a lot of power and the current is being limited. And lastly, sometimes array damage or even theft, depending on the region and the market, can occur. And it's not always, you know, easily visible why the PV voltage is not, what it should be, and you can sometimes detect theft or array damage. When I refer back to that application early in the railroad, that's an interesting industry that has a lot of, having to deal with vandalism. Railroad tracks are remote. People love to walk down them, and there's lots of rocks available, and they see PV damage on those arrays. So that's something that is kind of a real world condition that has to be addressed. When you get into looking at the battery capacity and what is the battery's overall health, obviously, looking at the voltage and making sure that your loads are up is useful, but you also want to make sure is absorption being reached, because you may have PV going in every day, but if you're not getting into an absorption stage, especially critical for lead acid batteries, to mitigate, sulfation, then you're already borrowing, you're already operating on borrowed time, because if that sulfation occurs, the system could go down at some point in the future and you're losing capacity. What is the balance of the power? Looking at the amount of current or amp hours coming into the battery versus what's going out. You only have 5 to 6 hours to charge during the day. You might have a load that runs 24 hours a day. You have to make sure that that's balanced, and looking at that input and output again over several days during different weather periods is pretty critical. Deep cycle risk, are you getting into any really extremely low states of charge of the battery, where you could be deep discharging it so often that you're going to incur damage? You may not be there to see that during those times, but when you look at a graph over time, you can see when you're, bottoming out. And in the case of lithium batteries, you also want to be sure, while they can be cycled more, you still want to maintain a healthy, low voltage disconnect point. And in the case of lithium batteries, they're a little more intelligent. They won't just get deep cycle damaged, but they may actually turn themselves off if they're taken too low, because they have a disconnect often built in internally. And you definitely want to stay away from that, because that will take the whole system down. And proper design can allow you to mitigate the risk for that. And lastly, low temperature, has an impact on all systems. PV modules happen to like it. Batteries definitely do not. And in the case of lithium, as it's being used more and more, sometimes there's an evaluation of a site. Northern Canada may not be a candidate for lithium, but Florida most likely would be, because of the temperatures. And they typically can't be charged below a freezing point. But as we're seeing more and more, the technology is always changing. And with some of them having heaters, maybe that is an opening for more lithium penetration in those remote applications. Okay, so here is an example of what I want to talk about a little bit. This is our MSView software. We've done some really granular data logging every few minutes, and you can really get a nice sharp graph to see what's occurring in the site. And whether this is MSView or any other software, which I'll talk a little bit later, my point here is that you want to look at the granularity of the data. You want to see all the little nuances, because taking a data point only once an hour or a couple times a day may not tell you the complete picture. So if you look here, you can see pretty much in the middle, if you can make out the graph there, that's pretty much a perfect solar day. You've got a high VOC, you've got the VMP there, and in the blue and the green on the upper portion. You've got the battery getting a perfect charge in the yellow in the middle. And the blue line at the bottom inside the power curve is a perfect absorption, turning the current from 100% all the way down to float levels. And that's really what you want to see. And if we saw that every day, I think our jobs would be a lot easier. But more often, you're going to see the third graph on the right there, which is erratic solar conditions, a battery that's going in and out of charge, and a load that is constantly drawing on the battery. So this kind of information is useful. And with MSView, you can save this to a local data log file, or you can download the internal data log file from the controller. But when you start to get cloud connectivity, you can see an even greater amount of information. Now, here's an example of our dashboard with live view. And in looking at this application here, those are just daily values, but what you see are cumulative data. So that's amp hours provided by the voltage from the array. You've got input and output from the battery as well, or net current in some cases. You've also got maximum battery voltage that's been logged every day. So even if you don't have connectivity all the time, you get a pretty good sense of what the travel of the battery is. Is it discharging quite low? Is it reaching a full charge every day? And then along with that, we also have Morningstar's diagnostics along the bottom, which will give you a good idea of faults and alarms. So you can see that I had a load disconnect, or I had a high temperature alarm at a certain point, because it'll flag those every day, and you can go back, and often that will be the reason why you may have had some problems. Here's a quick zoom of a ProStar MPPT, and I just wanted to pull out those two columns there in the middle, because when you look at amp hours charge and amp hours of load, then you're actually seeing, that you've got a pretty decent balance, and you want to make sure that obviously you're putting more in than you're taking out, or else your site, will eventually go down after a couple days of inclement weather. So you can zoom into that and see that on any of our products with EMC1. So to talk a little bit about load control, because this is an area we specialize in, doing so many DC-based systems, or so many systems that are not, basically there's no user on the site. They have to run autonomously. So you've got to sort of put a good plan in place and then leave it and hope that it executes fine, for weeks or hopefully years on its own. And a lot of times this has to do with really looking at what your load draws. So understanding the load behavior is really critical for these applications as well. A lot of times, residential is a little bit different, because, you can conserve power, you can start a generator, you can actually curb the behavior of the user by telling them, it's best to run heavy loads in the morning, make sure you've got plenty of solar resource. You don't always have that ability with an off-grid site. You typically don't. So you want to really understand, do they have a constant power draw, the loads and equipment? Are the loads running intermittently? Is it something that turns on and off, and is that a predictable pattern? They may have a low constant draw, but there could be peak periods where there's surges of power, and this really may vary quite a bit in the sites. Here's a quick example. One of the applications that we do in industrial is, as I mentioned, process automation for a lot of the energy industry. And what you'll see there is they have a lot of communications, but it's really efficient, really low power. But they do have certain things that occur, such as turning valves on and off, or running pumps. And this graph kind of gives a good illustration of, over a certain period of time, what is the actual delivered power that we're supplying for the loads. It seems pretty low, and pretty consistently low, with just a few periods there where there was some kind of a process going on. But if you were to actually graph the peak power draw, and if you didn't have the sort of resolution that you'd want to have with these sites, you may miss that even though your power draw is overall on average pretty low, you have some pretty high peak periods. And if those loads actually draw too much power, more than you're counting on because they're not really running but just a few times a day, such as pumps or heavy equipment, then you might not get the full picture. And this is nice because when you have the ability to measure load current, you not only get throughput and amp hours, but you also can see your maximum current draw. And sometimes that can be pretty substantial. Okay, so just a few more notes there, as I said, on load, consuming what is expected. Are you seeing outage periods? Did a load drop? Was it due to a malfunction? Was it due to an LVD, or was it maybe there a wiring fault in the system? Is the system able to recover that energy storage and put it back in, regularly throughout, the weeks or the months? And you also really want to look at the trends and the trending data. We see a lot of, when we work with advanced integrators of our products that are looking at putting our controllers into other systems, they're really taking the data monitoring to the next level with other types of we can get into all the buzzwords and terminology, but you name it, machine learning, AI, they start to analyze that data over time and they look for anomalies, like why is this system not behaving like the others? And it's more easily detectable when those problematic sites can stand out when you have that ability to monitor. Okay. And then also, as I mentioned, the cold winter months, when we see a lot of integrators and systems designers that we work with doing system sizing, doing a complete off-grid site evaluation with sun hours and, a PVSys or an NSOL system design, obviously they're going to design for winter applications and really what is the worst case scenario for off-grid, because there's not always a generator to start. Okay, so that's just a little bit of an overview on some of the data and some of the insights that we want to look into in these systems. And one of the things that I wanted to talk about in the middle here is that, we are seeing a lot of a transition to lithium batteries. So with that comes, a little bit different behavior, a little bit different amounts of data. As I said earlier, with cold temperatures or deep discharging, they're treated slightly differently. And what we are doing in a lot of cases with addressing those needs of a lot of our customers is working with specific partners with our energy storage partner program to work with the engineers at those companies, find common ground on what exactly we want the charge set points to be for those batteries so that we can make them available to customers and they have a certain degree of confidence and the knowledge that the support of that battery is backed by both the battery manufacturer as well as Morningstar. And in the case of with ALD-E, they have a battery line that we also did the same process for. And therefore, when you're able to see that presentation about that product, you'll know that there's a preset for that specific battery in Morningstar's web pages that you can download and apply to any of the products that have data connectivity that I just talked about. So with the ESP program, you see that there is a lot of support for batteries in the industry. It's commonly growing, and you'll see that we're taking into account these types of voltage settings that I was discussing earlier. With batteries also growing in intelligence and communications, there's more opportunities for connectivity with them as well, both with the site equipment, also with the charge controllers and inverters. Clearly, there's a lot of closed loop interface going on between both charge controllers and inverters in the industry. These existing products, we provide support for, at the very least, open loop control. And we have configuration options here where you can load presets for these battery types using MSView. You can program it into that controller, and then your controller is pretty much preset for that specific battery type. And a lot of integrators and OEMs will do that consistently if they're providing a controller and a battery as a package. And when we discuss these types of charging, it's important to note in the case of these batteries that we kind of have three different classifications that we put the batteries into. And open loop would be the most standard. You're charging it across the post just like you would any battery, like a lead acid. And open loop is just a set of charge set points, regulation, float, everything has already been determined. And there's not any type of current management with the controller. As some batteries offer state of charge capabilities and they open up data, through similar protocols, just like Modbus, which we've been working with for many years, you'll see that you can start to get shared data. And that information, such as a really accurate state of charge from the battery, is only going to help to complement some of your data logging that I was discussing earlier for these off-grid sites. So you can get communications data and you can get that state of charge or other information out of the system. And then lastly, with closed loop, you're looking at, in the case of a charge controller or an inverter, the data is not only collected and shared between the products, but there is a link between the products that allows the controller or inverter to work with the battery to know exactly what level of current it wants. If it can actually give it a much higher level of charge, and that battery is telling the controller, you know, just don't hold back, give me a 1C rate, I can handle it, then the controller knows that it can do that. So we kind of classify them into those categories. So as I mentioned, on the category of batteries, as the intelligence is improving, you're going to see clearly cell balancing is built into all lithium batteries, but we're seeing state of charge. We're seeing heating capabilities come with batteries. When you're in extreme low temperature environments, they're able to provide some heating of their own so that they can get over the threshold, which they can actually be charged. And we're seeing the same types of communications that we've supported. RS-45, CAN bus, obviously a newer one specifically for batteries from the vehicle industry, and also even some wireless standards such as Bluetooth or Wi-Fi. And as these values get integrated into the data logging alongside the controllers, you can now add things like cycle count, and getting an idea of the amount of life that's left in the batteries, maybe even state of health. Um, Temperature operating range, if the batteries are heating up or getting to a point that they can't be charged, and also peak current. A lot of batteries have different peak currents, which is something you want to pay attention to, because the types of batteries you may see in the ESS or storage industry, where they're kind of just storing and buffering and pushing and pulling current in and out of the grid, maybe some kind of a time of use schedule or working with a grid connected inverter, is a little bit different than peak currents and surges that you may need a battery to be able to handle if it's going to work in an inverter that could be rated for several kilowatts and might have a 2x surge, up to 6 or 8,000 watts. You have to be sure that that battery is going to be able to handle that current level. So okay, so in talking about all these data needs and how you can collect this information and evaluate it, what I wanted to do was change in this area specifically to how do you do it at scale? Okay, so this is no longer our, the web dashboards and MS View software where you're connecting to a couple controllers or configuring them, but the challenges you experience when you have to manage things in a large deployment. And if you're not familiar with some of the applications Morningstar is in, I would encourage you to take a look at our website. We have dozens of case studies and system applications. These are, in this case, a wireless internet service provider or WISP infrastructure. There is really growing a lot, and as you're hearing from these satellite companies that are deploying these new constellations, such as Starlink and others, there's going to be a lot more connectivity available, and we can luckily put it wherever we want, which makes it ripe for solar power. So with these kind of massive installations, you have to do things a lot differently. So in a lot of cases, we're working with a variety of software integrators and partners and people in these specific industries to find out what applications they want and need in order to get the data and make sure that the charge controllers work well with their systems. So this is an example of a network monitoring solution. It's a server-based application, and obviously this is a focus we'll be talking about a lot in the coming months and throughout 2021. And this monitoring dashboard is able to get data from hundreds of sites, if not more, and collect data and store it in a cloud database. If you're familiar with Amazon Web Services or Google's cloud products, you can easily store it. Many users can access it. It's going to give you proactive notification of alarms and other such monitoring, problems in the system, and you can monitor the sites at a great deal of granularity. In this application, these are an example of Morningstar products, and at different points in time, if they had, an alerts or notifications were set up about when the battery was full, when the battery was discharged, you can see a lot of that information on a single page. And then they have their own graphing and in some cases reporting capabilities. Like if you just want to filter down to an example of where systems that are, lower than a certain battery voltage, only show me those and hide all the others and filter that out. Those reports can be run. Or if you're looking to compare systems that are very similar in design but have a difference in their data profile, you can filter out the systems that are, at a certain level of health and just focus on specific products. Even geographic capabilities, in a certain region or by a certain name can be monitored, and you can see all this from the cloud. Okay, so the last thing I wanted to say about the cloud connectivity is when you look at SNMP as a protocol, there's a variety of third-party applications that will support SNMP for no other reason that it's an industry standard. And therefore, it doesn't require a lot of integration work. It's something that can be used more or less out of the box. And as I mentioned earlier in the presentation, can be done so right along with networking equipment. And the nice thing about this is it's not necessarily something that's offered by a manufacturer. It's agnostic. So you can actually have the data yourself. You can keep it on your own server. A lot of these are easy to install because you can get, some of these applications in a couple minutes. You can just spin up, pay by the hour, a service in the web and collect data of this nature. And you have the ownership, you have the monitoring capabilities, and you don't have to rely on, an industry or manufacturer to actually provide this data yourself. Okay, so the last thing I wanted to talk about, since we've kind of covered a little bit about array size, storage, and other types of data that can be collected, is Morningstar String Sizer is also a nice complement to, rounding out your system design, because with the right applications and data, you can actually get the latest modules, in our database used for, your system designs. And obviously modules have changed quite a bit over the years. We do a lot of design still around nominal designs with our PWM controllers. Those would be 36 and 72 cell. But now that, modules are into the, high 300s, even 400 watts, and there's a lot of new cell configurations, you have to look at some different options for, sizing, especially with MPPT. Make sure you're in the right voltage range and make sure that you're not going to oversize the controller too much, but a little doesn't hurt. So some of the updates I wanted to cover is we recently went through our applications team here. If you know, familiar with Doug Grubbs, he actually put in the latest touches for the update for our string sizer, and we've got a lot of new updates. Hundreds of module manufacturers, of course, are represented, and I'll take a guess at just 50,000 plus total modules in our database. This is constantly being updated and is refreshed usually about every quarter or two with the latest modules. And we've also provided some software enhancements that give you the ability to best handle some of the newer technology that we've seen in modules over the last couple of years, such as the perk cells, which are, if you'd like to Google and read about that technology, they're just a little bit on the higher voltage side per cell. So, accommodating those in our string sizer and making sure that we're giving you the best output in terms of information on string sizing is pretty important. And we've got to take those latest advancements in the industry into account. And what we've got is some color keying for different levels of system sizing. So here's a quick output from our string sizer. We did a quick configuration. I believe this is about a 340 watt PV module, and you're looking at our Tristar MPPT 60, and you can hover over those different sizing configurations and you'll get notifications or alerts on, if the system is sized correctly, if you're going to see diminished power, during peak periods of time. Like in this case, this is actually a goal many times to strive for, which is moderate oversizing of the array. With Morningstar's controllers, just like grid tie inverters, you can actually put more wattage on them than they're rated for. The battery current will still be limited at the output, but it's not going to break, it's not going to go over the current limit of that battery breaker, and it's going to keep the wattage right at the maximum power point. And if that exceeds the controller's rating, it's going to just clip that power. But like with standard grid tie sizing practices, you'll often find that putting more wattage on the controller than it is, designed for it to handle continuously is a pretty good design practice, because you can see more power generated during lower levels of solar insolation. So you might actually get more consistent power or more total throughput, and it allows you to best maximize the controller, which is a critical part of the system, and one that you may not have the ability to expand as easily and cheaply as you can with a solar array, which are reaching new cost lows. Okay, so system sizing is an important one to cover when it comes to the string application. And then what you'll see is in this example, we have color coding that's been integrated. This actually conforms to standard for color blindness as well for the web. It's actually a standard they provide. And this gives you a quick way to see, thumbs up, thumbs down. Is this a good optimal configuration? Is it optimal with a little bit of oversizing? Are there any voltage, current, or MPPT power warnings that you should be aware of? And really, it can lead to some, great system design. And this goes for PPT as well as PWM controllers. Our entire line is in there. Okay, just a couple application photos here I had at the end. This was an application where you can really see the benefits of our high voltage controller in this case, and why proper configuration of the array is critical. In the bottom left, you can see an example of where these were 600 volt charge controllers with an array that was actually located quite far from the system. It's hard to see the scale there, but those are that's actually like a telecom shelter building there with a pretty substantial antenna. And those 600 volt controllers, 4 of them, are handling about 12 kilowatts of power. And there's several hundred feet between the solar runs there, the PV wiring runs. And they had to run it for high voltage. And you can see how far north it is because of the vertical nature of the orientation of the solar array. So here's an instance where, making sure that your voltage is correct, accounting for that voltage drop or minimizing it with high voltage is a pretty critical application. Okay, so that is the end of the presentation, and I was just going to drop out real quick from the presentation just to give a quick example, as I showed you with a string calculator before, some of the values there, but in an example here of our configuration with the PV array, all the modules that have been recently added to the database, you can search and sort by, and then you'll get your configuration. You input only the battery voltage low and high, the controller that you're using, along with the PV module. And then, of course, you get your historic low and your average high temperatures so that we can account for the changes in the voltage. And when you do that, you get a nice configuration. This is something you can easily print, and then you can hover over the various configurations of the array in order to make sure that your system is optimal. It's optimal with a little bit of power clipping. And if I go up too high, you're going to see significant oversizing, greater than 30% of nominal power, indicating that the system is really, you're putting way too much PV on. It's not going to be of an economic benefit because it's just oversized. In some cases, if you actually exceed the voltage open circuit, then you would actually get damage, and you'll be notified with that actually with a red indication. Luckily, we don't have any of this in this application here. Okay, so that is the string sizer. So I hope that that was a good overview of a little bit about some of the data capabilities of Morningstar's products. And we'd love to provide support on some of these software tools, system sizings. As I mentioned, we do a lot of not only our support team as well for Morningstar controllers, but even on the application side, getting a good idea of these design constraints can really help you make a better decision in the future. And I know that Alti's got a lot of these capabilities as well to really give you not only the support on the system configurations, but also all the product line that can enable that. So I will now, I think we can maybe address, I have not looked at the Q&A, so hopefully the rest of the team has been able to address some of the questions.
Yeah, thank you, Brad. That was a great presentation.
Thanks.
I do think that your team has been kind of answering Q&A as you've been going along, but I didn't know if anybody else had another question or two. We have a couple minutes left before we have to get you guys off to the next session. But I think you may have to type it in, and then we could probably answer it live.
Okay. I'll take a look at the QA. Let's see, Kyle, I know you were monitoring. Did you see any specific questions you'd want me to answer audibly? that might be good to point out. I did see a question. This is of course qualifies for an NABCEP credit. So that was one of the low-hanging ones I could take real easily.
Yes, thank you. We should have mentioned that at the top that we'll get all the attendees' names and emails over to Morningstar so they can issue the credits. Thank you.
Okay. Let's see. I got one question here, and if the rest of the team sees anything of interest, just please let me know. I got one question here from Jacob that says, occasionally the end user is looking for a low noise option for sensitive radio sites. Are there any Morningstar controllers that are better suited to this application? All of our products generally can do quite well in telecommunications. I wouldn't say any of them are any something you should stay away from. They're all perfectly suited for telecommunications. I will make a couple points though. PWM is commonly used with applications that are very small. Years past, this is less so the case now with the new digital technology of a lot of this equipment, but in years past, some of the products, PWM was at a 300 hertz pulsing frequency, and if there was noise on the battery line, sometimes the equipment would be a little bit sensitive to that, and you would see harmonics based on that frequency that would actually be audible or that they would hear. But that's really only on older analog equipment. You can disable that PWM function on some of the products like the ProStars. There's just a simple switch and you can turn that off and go to an on-off style charging, which will often eliminate that noise. It's really become less and less of an issue. Our tech support team would know best, but we have not received a lot of comments on it. Mostly with MPPT and a lot of digital communications, the frequency is so high and such low power that there's not really any interference that we've run into. And I would definitely recommend PPT because it's kind of the core of our telecom offering now, such as the Tristar. So that's probably your best bet all around for telecom.
Hey, Brad.
Yes.
It's Mark. I just wanted to add, and that was a great answer. I just wanted to add one more thing. We do get a lot of anecdotal information, and we'll be doing a case study on this, that we're very popular with ham radio operators, amateur radio, where certainly there's a lot of radio sensitivity and interference sensitivity on those sites. And a lot of amateur radio operators are using Morningstar controllers for that reason. I'm going to be exceptionally quiet.
Okay, good. Yeah, and that's an example of like an analog transmission. So if they're quiet, then that's a good case for being a good choice for the product. So a couple other questions real quick. Let's see, the months of data storage. If you're talking about capacity, let me just give a quick answer to that on an overview. Most of our products have an internal daily value that they log once a day that will be stored into the controller's memory. And that can be downloaded from the site remotely. It can be retrieved from the site, or in the controller, it'll reside in the flash memory. And depending on the product, it could be as little as 30 days, which is still really beneficial for a Sunsaver MPPT, all the way up to 200 days of data logging or more, depending on how much data is actually being captured. And that's cyclical. So you always get the last 200 days, which is nice because it counts back in time. And that's usually enough of a time period to see what was happening at the site. If you had to investigate, you can look back several weeks. So that's stored locally. When you get into downloaded data, one of the benefits is, of course, unlimited storage, and that's where we're seeing the push to the cloud, where you don't have any kind of restriction, and it really is just based on the interval of the data you want to capture and your web service or your database. And that's where some real insights come from, but you have to be able to manage the site data as well. Okay, so we provide little data logging. Small or large needs are available. Let's see. Quick difference, the question between the Tristar and the ProStar for data logging, I would have to get back to you offline, but I believe the Tristar data logging right now, I believe, is 90 days. The Tristar MPPT is about 200 days. And I believe the ProStar, the newer generation of the ProStar, is also, I believe, over 200 days. I'm not sure the exact number. It could be as much as a year, but the newer generations of the ProStars have quite a bit more data logging capability. That's both the PWM and the MPPT built in to their flash memory. Okay. Yeah, we can, I'll take a look and we can see if we can answer that in a more routine, orderly fashion offline by checking all the specs.
Right.
Okay. I think
All
that's
right.
it for most of the questions. Andrea?
Yeah, thank you, Brad and team. Again, really appreciate your time. And all the attendees, we'll see you at the 3 o'clock session if you're interested in doing some further networking with the manufacturers today. So thank you all very much.
Okay. Thank you very much. We appreciate being part of this.
Bye-bye.
All right. Take care.